Today's Bellwork is to determine if these triangles are proportional. The only way we can determine if these triangles are proportional is if their slopes are equal, then any triangles are proportional. So we must look at the slope of this line and this line, simplify it, and determine if they are equal. And if they are equal, then we can prove that they are proportional. The slope of this line has a rise of 1, 2, 3, a run of 1, 2, 3, 4. Therefore, the slope of this line is 3 divided by 4. The larger triangle has a rise of 1, 2, 3, 4, 5, 6, a run of 1, 2, 3, 4, 5, 6, 7, 8, and therefore its slope is 6 divided by 8, which can be simplified by dividing both numbers by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. We see that this slope is 3/4. This slope is also 3/4. Therefore, we can conclude that these two triangles are proportional. Now, let's determine which of these triangles are proportional and justify. Remember, in order to determine if triangles are proportional, their slopes must be equal. So we start by finding the slope of this first triangle. The first triangle has a rise of 1, 2, 3, 4, 5, a run of 1, 2. So the slope of this line is 5 divided by 2. The slope of this line is finding the rise 1, 2, 3, 4, the run 1, 2, 3, 4, 5, which is 4/5. We can see that because these two slopes are not equal, therefore these two triangles are not proportional. So we check the third one. This third triangle has a rise of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A run of 1, 2, 3, 4. Therefore, the slope of this line is 10 divided by 4. Simplified, 10 divided by 2 is 5. 4 divided by 2 is 2. And we see that this slope is 5/2. The slope of the first triangle was 5/2. Therefore, we can conclude that these two triangles are proportional, and this third triangle is neither proportional to the first one or the last one. Another thing we must determine using slope is to determine if these points lie on the same line. Well, they certainly look as though they're on the same line, but that is not proof enough to determine if they lie on the same line. If we can conclude that the slopes are equal, then the points are on the same line. So we find the slope from this point to that point by finding the rise and the run. So the rise of this slope is up 1, 2, 3, 4. The run 1, 2, 3, 4, 5. Therefore, the slope is 4 divided by 5. Now we must find the slope from this point to this point. So we find the rise 1, 2, 3, 4, and the run 1, 2, 3, 4, 5. This slope is also 4/5. Therefore, we can conclude that these 3 points do lie on the same line. Which 2 points do lie on the same line and justify? They certainly look like they are on the same line, but we must justify it by determining if their slopes are all equal. So we are going to take the first 2 points and find the slope of the line that connects this point to this point. So this has a rise of 1, 2, 3, 4, 5, 6, 7. This has a run of 1, 2, 3, 4, 5. Therefore, the slope of the line that connects the first point to the second point is 7/5. Now we must determine if these 2 points have the same slope. 1, 2, 3, 4, 5, 6, 7 is the rise. 1, 2, 3, 4, 5, 6 is the run. So this slope is 7 over 6. As you can see, these 3 points do not lie on the same line because the slopes are not equivalent from all 3 points.